Example 1, mutually exclusive events. A card is drawn at random from a pack of 52. What is the probability that the card is a club? We know that in a pack of cards that there are 13 clubs. It's one of the 4 suits. So the probability of it being a club, I'll just use the letter C here for club in this question, would be either 13 out of 52 or 1 in every 4 cards is a club. The second question here I'm being asked is, what is the probability of it being a king? The probability of being a king, well, we know that there are 4 kings in a pack of 52. We also know that there's 1 in every suit, or 1 in every 13. That's the way of writing this. Question 3, we're being asked, what's the probability that it could be a king or a club or a king? The probability of club or king follows the rule here for events that are not mutually exclusive. This is not mutually exclusive because there is one card that is the king of clubs. It is both a king and clubs. So if you thought about it, one way to think about this would be is that there are 13 clubs and 4 kings, but one of those clubs and one of those kings is the king of clubs, so we're double counting. So you would have to take away the double counting, that 1. So the formula for this is that the probability of being club or a king is the probability of club plus the probability of king, take away the probability of it being both a club and a king. You could see why this works if you created a Venn diagram for the problem as well, which I'll maybe do in a second. But just giving an answer to this. So probability of club is 1 in 4, probability of king is 1 in 13. So we take away 1 in 52. And if we stick that into the calculator, we see that the answer is 4 out of every 13. We see that there's 16 cards in the pack, different cards in the pack that are either king or club. So that reduces to 4 out of 13. So that's the answer. You could draw a Venn diagram to show this. I'm going to draw it here and maybe take it away again in a second for the next question. So if I drew a Venn diagram, and this is a Venn diagram showing probabilities. So we thought about the probability of it being a club. And the answer to that we know is 1/4 or 13 out of 52. I'm just going to leave it in terms of 52 for the ease of this question. The probability of being a king, we know that that's equal to 4 out of 52. And the probability of it being both, this intersection here, there's one card that is the king of clubs, so there's 1 out of 52 chance you can pick the king of clubs. So if I take the 1 from the 13, there's 12 in this space that are clubs but not the king of clubs. And there are 3 that are kings but not the king of clubs. And you would see if you added up the total inside the circles to get the probability of being a club or a king, you would see it's 12 and 1 and 3 divided by 52, which is 16 out of 52, which is the same answer we got here, 4/13. So we could see why it makes sense, this formula that we have as such. So let me just highlight the formula here. This is worth knowing. And this is the formula for events that are not mutually exclusive. It's simpler if they are mutually exclusive. Well, this formula still works, but it just happens that the overlap is 0. So this formula is always true. So part 4, the probability of it being red. We know that half the cards are red, or if you want, 26 out of 52 are red. It's a half if you wish. Then we're asked the probability that would be a queen. So the probability of a queen, we know that there's 4 queens in a pack, or it's 1 in every suit, 1 in 13. Then we're asked for the probability of being red card or a queen. So again, this is the same type question we had a second ago. So probability of being red or a queen is equal to the probability of it being red added to the probability of being queen, take away the probability, I'll just fit it in here, of it being both red and queen. Okay, so again, you could do a Venn diagram if you wish to solve this. So the probability of it being red, we see is, I'll leave it all over 52, just to make it easier, maybe 26 over 52. Of it being a queen, we see that that's 4 out of 52. And of being red and queen, we see that that's the same question as last time, really. That's 1 out of 52 I'm subtracting. very similar at least. So when we add these together, we see that we're getting 29 out of 52. And that's the solution here. Again, you could argue this question using a Venn diagram approach like we did last time as well. But you see, we're using really what is essentially the same formula as before.